Let's look at one more example. Here I have the marginal cost of producing X units of a commodity is given by C prime of X is equal to 0.3x squared plus 2x, and the fixed cost is $2,000. We would like to find the cost function C of X and the cost of producing 20 units. So here we're bringing back some ideas from chapter 2 way long ago. We have this idea of marginal cost right here. Marginal cost, remember, that's just the derivative of our cost function. We don't need to overcomplicate this. So I'm starting with C prime of X is equal to 0.3x squared plus 2x. I want to take this somehow and find C of X is equal to blah. And then the cost of producing 20 units. Once I have C of X, that'll be easy enough. I'll just plug 20 in for X. So I have the derivative. I want to work my way back to the original function. Sounds like a job for indefinite integrals. So I'm going to integrate 0.3x squared plus 2x with respect to x. If you want to, on the other side, you can say, well, we're integrating C prime of x dx. And when I integrate that, I'm going to come up with a C of x. And I think that might be helpful just in remembering what we're dealing with, or if we're dealing with the derivative or the antiderivative or the function. So here I'm going to integrate each of these two terms, just a power rule for each of them. So I'm going to add 1 to the power. I should have x to the third divided by my new power of 3. That'll give me 0.1x to the third. Plus over here, add 1 to the power x squared divided by 2. That'll cancel my 2's. And then, of course, plus my constant of integration c. Here in this case, I'm going to choose a different letter just because we already have c of x, and I don't want to get confused by it. So I'm going to say, how about d? I just need some constant over there. So now, I'd really like to know, well, what is my cost function? Well, this is a cost function. It's actually infinitely many cost functions because I don't know what d is. I don't know what that constant of integration is. So I would like to find that point. Only the problem is we don't have an ordered pair like we did in the last couple of examples. We don't have, they don't outright tell us, hey, C of blank is equal to blank, right? We don't have that piece of information. Well, actually, we kind of do. It says particularly right here, the fixed cost is $2,000. So when I say the fixed cost is $2,000, really another way for me to say that is no matter what, I have to pay a cost of $2,000. In particular, I have to pay a cost if I manufacture 0 units. That will still be $2,000. So whenever you see something about fixed cost, that's really what this is trying to say. It's trying to say C of 0 equals 2,000. No matter how many units I produce, including 0, I have to pay at least $2,000 in costs. So this gives me a way that I can solve for d with. I can say, well, C of 0, that's equal to 0.1 times 0 to the third plus 0 squared, plus I don't know what d is, so I'm going to leave that there. And all of this is equal to, we said, 2,000. So I have 0 plus d is equal to 2,000. So d equals 2,000. So that means my cost function, C of x, is equal to 0.1 x to the third plus x squared plus d, we just found that as 2,000. So there is my cost function. Here's the first part of my answer. So find the cost function. We just did that. The other piece it wants, it says, and the cost of producing 20 units. This one is relatively straightforward. You're just going to evaluate this at x equals 20. So you're going to look at, well, what is C of 20? 0.1 times 20 to the third plus 20 squared plus 2,000, and you would go and calculate that. I'll leave that as an exercise for you to do. One thing I'll mention about this problem, a really bad habit I'll see some students use is they'll say, hey, if I see C of 0 equals 2,000, I feel like that gives me a free pass to just conclude that my constant of integration is equal to 2,000. Please don't make that mistake. It's a very, very easy mistake to make. Look back at our last example. Here we said y of 0 is equal to 8. Notice that our constant of integration was not 8, it was 10. So we want to be careful. You do need to go and actually plug in 0 for x and set your function equal to 2,000 to solve for that variable. Otherwise, it's going to be really, really easy to make a mistake when you are solving for that constant of integration.